Hi folks, in this next video in scientific notation, this is actually our case 2. This is a continuation video, so don't forget, you must check out my first video in scientific notation in order to get the big picture of it, or the whole picture, shall we say. Now, this is our case 2. We are talking about converting a number, a decimal number to be exact, into scientific notation, so that we can write it much better compared to one with a lot of zeros. Okay, so the case 2 is something like the opposite. Okay, actually the opposite, the exact opposite of case 1, wherein the decimal comes first, decimal point comes first. Actually, the decimal, shall we put it decimal point, sorry, decimal point comes first, then followed by the non-zero digits. Okay, again, the decimal point comes first and then followed by the non-zero digits. So what will we do if this happens? We will move the decimal point to the right now. Okay, going to the right. So look at the arrow here. So right is here. And then n is a negative integer. N must be negative. Okay, so it must be a negative integer. Okay, so one example will be like this. Okay, we can see in this example that the decimal point comes first, which is shown here, and then followed by the non-zero digits. Again, when I say non-zero digits, these are, well, these digits which are not zero. Okay, so 2 and 3 are the first non-zero digits, and we see the decimal point comes first. So if this happens, we will move the decimal point, obviously going to the right, in order to achieve the value of a. Again, our scientific notation must be in the form of a times 10 raised to n. A times 10 raised to n. We're in a, if you can remember, we're in a must be at least, or it must be at least 1, but strictly less than 10. So it should be 1.00 until 9.999999 inclusively. Okay, so we need to achieve this value of a, and n must be an integer, and in this case it should be a negative integer. So shall we have it? Let's move this decimal point going to the right until we achieve the value of a. If we move it here, do we achieve the value of a? No, it's still 0. If we move another one, no, not yet. If we move another one, no, we have 4 zeros there. If I move another one, not yet. And voila, if we will move until here, we will have a value of a which is 2.3. And this is exactly, 2.3 is exactly between 1 and 10. Exactly between 1 and 10. So that's our value of a. So therefore, given this, shall we say, a formula for our scientific notation, we must have the value of a as 2.3. So this is equal to 2.3 times 10. And our n is said to be negative because we're going to the left. So we count the number of steps. We go to the left. We went to the left. So we have 1, 2, 3, 4, 5. Okay, so 5 steps going to the left. Okay, 5. And don't forget, it should be a negative integer. So therefore, 10 raised to negative 5. Can we write this properly? It should be negative 5. Okay, and this is our answer for this example in the case number 2. Okay, so we say that 0.0000, that's 4 zeros, 3 is just equivalent of writing 2.3 times 10 raised to negative 5. Okay, why do we use this? Imagine a very microscopic thing, a nanoscopic thing, shall we say. It's going to be very, very small with a lot of zeros. So you don't need to write all the zeros. Instead, why not use the scientific notation instead? Right? So that's the use of scientific notations. So after this video, I'm going to create an exercise video wherein we will do a lot of things, or a lot of items or examples for scientific notation. For this video, I'm just going to show first the concept of it. So I hope you will like and subscribe, and see you in the next video in the exercises. Okay, thank you very much and see you soon.